Understanding what if an introduction to counterfactual explanation. In simple words, this is about understanding what could I have done differently to get a better results. The idea is not just for AI, it applied directly to your academic performance. So here we are going to discuss counterfactual explanation, how it is helpful, what is the importance of this explanation, and how we can get the better results. What if the power of counterfactuals? Imagine you got a bad grade on a test. What if you had studied just a little bit more? Would things have turned out differently? Take the core idea. Counterfactual explanations give an insights how output gets changed with the influence of the output. Or in another word, we can say that how output is changed when we change the input. The key question, what would need to be different for a different results? That's exactly what counterfactual answers. Why do we need counterfactuals? What is the importance of these counterfactuals? Actionable insights. They tells us what to change to get a better outcome, not just that something went wrong. Trust in AI, understanding why an AI made the decisions, build confidence in the system. Fairness, they help identify and correct hidden biases in AI decision making. Learning and improvement. Crucial in education to give student a clear, personalized path forward. In another word, we can say that why do we need these counterfactuals? First, it provides actionable insights, not just problems but solution. Second, it provides trust in AI. If AI explains itself, we trust it. Third, fairness. We can detect bias, and most importantly for you, learning improvement, clear personalized step to do better. The basic of counterfactual explanation. Let's start from ground up. What does a counterfactual explanation actually look like? Now let's start from basic. What exactly is a counterfactual explanation? What is counterfactual explanation? A counterfactual explanation is a hypothetical scenario which shows smallest change to an input that would alter the AI predictions. Example, if AI denied a loan, a counterfactual might say, if your income was $5,000 higher, the loan would have been approved. What we conclude from here, it focused on actionable knowledge. So definition here, a counterfactual is a small hypothetical change that alters the outcome. Example, if your income was $5,000 higher, your loan would have been approved. Notice this is specific, achievable, actionable. That's what makes it useful. Real world student performance. Before AI predict student will fail the course. Before assignment, after assignment improvement, here progress, after middle term. So this is types of the say graph. What will happen after counterfactual pass by two more assignment and plus 5% midterm? This gives the student clear, concise step to improve, not just a warning that they might fall. So researchers confirm counterfactuals are among the most effective tools for guiding student learnings. Let's bring it closer to you. AI predict you will fail, but instead of stopping there, it says complete two more assignments and improve midterm by 5%. You pass. Now that's powerful because it gives you a clear plan. Nearest neighbor counterfactuals. What if we could learn from students who were just like you but succeeded? Now we move to our first method, nearest neighbor counterfactuals. Finding the closest what if, the core idea. Nearest neighbor counterfactuals looks for the closest data point in a data sets that have a different outcome. Imagine a data sets of student profiles and their grades. If a student is predicted to fail, neural network finds similar student who passed and examines what was different about them. The nearest neighbor is like finding your academic twin who made it across the finish lines. In another word, we can say that think of this as finding your academic twins. Someone just like you, but they succeed. Now we ask, what did they do differently? How neural network counterfactual work? First, identify the original prediction. The AI evaluates student profile and predict fail. Second, search for similar cases. The system scans for students with similar study habit, attendance and test score. Find a passing neighbor. A similar student who passed is identified in the datasets. Highlights the difference. The features that differ, like assignment score, attendance, becomes the counterfactual explanation. So here how it works. Take a process. AI predict your results. Find similar students. Identifies one who passed. Compare differences. Those differences become your improvement strategies. Visualizing neural network counterfactuals. Reading the map. Think of each student as a dot on map. Student who passed cluster in one area. Student who failed clustered in another. The neural network method draws a line from the failing student to the nearest passing student, and the gap between them reveals exactly what need to change. If this student has scored 8 more points on the final exam, have crossed into the passing zones. Imagine a map of students. Passing students are here, failing students are here. You are just on the edge. The system tells you 8 more marks would move you here. That's your shortest path to success. CNN based counterfactual. What if an AI could imagine a better version of your work and show you exactly what it looks like? That is GAN introduction. This is where GAN comes in. GAN stands for Generative Adversarial Network. Instead of finding examples, they generate new possibilities. Think of it as an AI imaging a better version of your work. Learning to generate what ifs with GAN. What are GANs? Generative Adversarial Networks are AI model that can create new realistic data by learning the hidden patterns within the datasets. In counterfactual explanation, GAN don't just find an existing example. They generate entirely new hypothetical scenarios that are both plausible and lead to different outcomes. So we can say here GAN can produce more diverse and creative what if scenarios that nearest neighbors method alone. So we can say here this GAN has two part generator it creates solution. Discriminator check if they are realistic. They compete and improve each other. This makes the output highly realistic. How GAN create counterfactuals? It has say generators Generators creates a new data points, counterfactuals. Then, when fed to AI, flip the prediction to the desired outcome. Then we are having discriminators. Discriminator act as judge, trying to determine whether the generated data point is real or fake. Adversarial training. Generator and discriminator compete, pushing each other to improve until the generator creates highly realistic counterfactuals. We can say here, this competition is what makes GAN so powerful. The result is counterfactual that looks and feels realistic. GANs in education. Easy feedback example. GAN could generate personalized, nuanced feedback for student written work input. An essay that received a low score can output a modified version of the essay suggesting specific wording changes, structural improvement, or additions that would have earned a higher score. This goes beyond simply pointing out what was wrong. The student what greatly look likes. Optimizer-based counterfactual: what if we could mathematically solve for the best possible? Finding the best what if, the math behind the methods. Optimization-based method treat counterfactual generation as a math problem to solve precisely. The goal: find the smallest possible change to the input that flips the AI decisions while making the scenario realistic and achievable. Think of it like finding the shortest path. The optimization process: first, define the goals, change the prediction from fail to pass, set constraint. Changes must be realistic. Example: income can't go negative, age can't be decreases. Measure cost: each change has a cost. The algorithm tries to minimize the total cost of change. Run algorithm: mathematical algorithm search for input which meet the goal with the lowest possible constraint. So in another word, we can say that the steps behind this optimization process are: define goal, set constraints, measure cost, find minimum change. It likes finding the shortest path in Google Map. Optimization in action: loan applications. Instead of saying earn more, it tells you increase income by $420 and reduce debt by $1,200. Very precise, very actionable. Bridging it all together, actionable courses. So we have three approaches: nearest neighbor, learn from others, GAN, imagine better scenario, optimization, calculate exactly changes, all aim for one actionable improvement. So, what should you remember? Always ask yourself, what can I change to improve my outcome? Because every what if is actually a roadmap to success. Thank you. Understanding AI decision, counterfactual, and recourse. Here we will see how we can change those decisions. The focus is on powerful idea, prototype-based counterfactuals, diverse counterfactuals, actionable record. By the end, you should be able to answer what can I do differentially to get a better outcome. Prototype-based counterfactuals, the what if game. What is counterfactual explanation? Imagine you applied for a loan and were denied. A counterfactual explanation answers, what if your income was $10,000 higher, then you would have gotten the loan. So we can say here, imagine a situation, if you apply for a loan and it gets rejected. Now instead of just accepting it, you ask, what if my income was higher? A counterfactual answers that exact questions. What needs to change to flip the results? It turns confusions into clarity. Why are counterfactuals important? So why this is important? First, understanding distance decisions. They reveal why an AI made an specific decision, making the black box transparent. Fairness. They can expose whether a decision was unfair or biased against a person or group. Trust. When people understand how AI decides, they trust it more and can challenge it when needed. So we can say here, in another word, first we have to understand decisions. AI is no longer black box. Second, fairness. We can detect bias. Third, trust. When we understand, we trust, and we can question. This makes AI more human-centered. Prototype-based counterfactuals. Learning from examples. Instead of one specific what if, prototype-based method use typical representative examples. Think of them as archetype or template from real data. If your situation resembles prototype A, here's what might have happened if you changed a key factors. This makes the explanation more generalizable and meaningful. In another word, we can say that now we move to our first advanced ideas, prototype-based counterfactuals. Instead of one single what if, we learn from typical example prototype. Think of them as standard profile of successful cases. Example loan application. Let's see this in action. Instead of saying increase income by X, we say people like you with similar profile succeeded when their debt ratio was 5% lower. Now this is a powerful because it is based on real patterns. It's generalizable. It feels more realistic. Therefore, this prototype-based counterfactual map the gap between your current situation and approvals. It incorporates original application, denied, prototype counterfactuals, and approved. Diverse counterfactual generation, more what ifs for better choice. The problem with just one what if, a single counterfactuals might not the best or only path to a different outcome. It could be too expensive, which requires changes that are financially out of reach. Too difficult, suggesting things that take years to achieve, not realistic. So we can say here a single counterfactual can be limiting. It might be too expensive, too difficult, not realistic. So we need alternatives. Diverse counterfactuals generation. This bring us diverse counterfactual generation. Instead of one path, we generate uh, many three steps. Generate outputs, generate options, diverse solution. Lets the user choice because success is not one size fits all. How do we generate diverse counterfactuals? GANs generative adversarial networks models like Counter-RGN generate realistic alternative scenarios that look like real data, considering constraints, ensuring what ifs are actually possible. You can't magically lower your age. Exploring features change. So we can say here, how do we generate these options? Using AI models like GANs, applying real-world constraints, exploring different combinations. The goal is simple: give multiple realistic paths to success. Job example. Let's take a job rejection scenario. Instead of one suggestion, we get three: gain experience, get certification, build portfolio. Now the student can choose which path fit me best. Interpretations here applications denied. Starting point explore alternatives. Gain experience. Seeks internship or entry role to build skill. Get certified. Complete recognized credential to boost credibility. Build portfolio. Create project that demonstrate your abilities. So diverse counterfactual shows that there's really just one road to success. We have to explore many roads. This is the key idea. So there is never just one road to success. Diverse counterfactuals empowers decision making instead of restricting it. Actionable recourse method making what is real. From explanation to action. Counterfactuals explain, uh, but actionable recourse answer. What do I actually do? This is where they become practice. What makes it actionable? For something to be useful, it must be feasible, coherent, personalized, efficient. If advice is not practice, it is useless. Care framework. Care is a structural approach. Instead of vague advice, it gives clear step-by-step actions. Example, save $200 per month. Reduced credit uses. Now you have a plan, not just a suggestions. KTFC in education. This becomes even more powerful in education. If a student struggles, the system says, practice these three types of problems. Now generate advice but targeted learning actions. Your path to success. Let's summarize the journey, understand the decisions, explore multiple options, take action. This transforms AI into personal guides. Future of AI. So what is big pictures? AI should not just predict, it should empower, prototype, learn from patterns, diverse, explore options, recourse, take action. Final thought. AI should not judge you. It should help you improve.